Section 3.2, we're going to look at synthetic division. All right, so we are, this is a kind of like a shortcut method for dividing a polynomial, any polynomial by a binomial. And it only works if the thing you're dividing by is a linear binomial with the leading coefficient of 1. So basically you can only have, it only works if you have x plus a number or x minus a number. It doesn't work if you have any other coefficient in front of this x or any exponent on the x. Okay, so it seems a little bit weird at first, but hopefully you'll see that it's actually pretty simple once you get the hang of it. So first we're going to do, I'm going to take the opposite of this number. So this is plus 2, so I'm going to go over here, I'm going to write -2, and I draw like this little half box around it like that. Then what I'm going to do is I'm going to take the coefficients of the numerator. So this would be an invisible 1. So 1, 7, 13, 6. I'm going to write those numbers over here, space them out a little bit, like so. Okay, then we're going to draw a line like this, skip a space there. Okay, so then we're going to bring down the first number, so bring down the 1. And then we're going to do 1 times -2 equals -2. And we write that here underneath the next coefficient. And then we add, which in this case feels a little bit more like subtracting since that's negative. So that's going to be 5. Okay, and then we multiply again. 5 times -2 would be -10. And then 13 minus 10 is 3. And then 3 times -2 is -6. And then 6 minus 6 is 0. So that last number there is the remainder. So we have a remainder of 0 in this case. So if we're dividing an x cubed by an x, we're basically, if you did x cubed divided by x, you would have x squared. And so when I fill in my coefficients for the answer, I'm going to start with x squared right here. So 1x squared plus 5x plus 3. So that division problem, the answer would be x squared plus 5x plus 3. Okay, that's the answer. All right, and then let's do the same thing for number 2. So again, here this would be -2 in the box. All right, and then let's write down the coefficients. All right, now you have to have a representation for each power of x, starting from here and going all the way down. So x to the 5th got skipped over, and so we're going to include a 0 for x to the 5th. So we have a 1 for x to the 6th. Then we didn't have an x to the 5th, so we have a 0. Then we have, for x to the 4th, we have -3, then 2, then -6, -5, 3. Okay. All right. And then we just bring the first one down. So bring the 1 down. And then 1 times -2 is -2. 0 minus 2 is -2. -2 times -2 is 4. -3 plus 4 is 1. 1 times -2 is -2. 2 minus 2 is 0. 0 times -2 is -2. -6 minus 2 is -8. -8 times -2 is 16. -5 plus 16 is 11. 11 times negative 2 is negative 22. And 3 minus 22 would be negative 19. All right, so in this case, negative 19 is the remainder. So I'm going to start filling in my x's, and I'm going to start with x to the 5th. So x to the 5th minus 2x to the 4th plus 1x to the 3rd plus 0x squared minus 8x plus 11. And then you take the remainder and you put it over the divisor. So minus 19 over x plus 2. All right, so let me write that out a little bit nicer looking. I've got my final answer is x, whoops, that's not very nice looking, x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 11 minus 19 over x plus 2. And that's my final answer. Okay. Okay. Number 3. All right, so in this case, so the opposite of negative 1 is positive 1. So positive 1 is going to go in my box. All right, and then I've got, for my coefficients, I've got a 1 for x to the 4th. And then I have no x to the 3rd, no x squared, no x, and then I have a negative 1 there at the end for my constant term. Okay, and then bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. And negative 1 plus 1 is 0. All right, and so this is going to be 1x cubed plus 1x squared plus 1x plus 1. X cubed plus x squared plus x plus 1 is my final answer. There's no remainder. All right. Okay. All right. Number 4. All right, so I have, okay, so the opposite of negative 4 is going to be positive 4 in the box. And then for my coefficients, I've got a 1 for x to the 4th, negative 5x to the 3rd, negative 1x squared, 20x, and then I don't have a constant term, so I'll go ahead and put a 0 there for that. All right, bring down the 1. 1 times 4 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 4 is negative 4. Negative 1 minus 4 is negative 5. Negative 5 times 4 is negative 20. 20 minus 20 is 0. 0 times 4 is 0. 0 plus 0 is 0. Okay, so I'm going to start with x cubed, x squared, x. So my final answer is x cubed minus x squared minus 5x. Okay. All right, so here on the next couple problems, we're basically doing the same thing, but it's just a different way of them asking the question, a different way of putting the answer down. So they're saying that basically we're taking this polynomial f of x and we're dividing it by x minus k. So x minus negative 4. So in other words, we're dividing it by x plus 4. Okay, so here it's like the sign has already been changed for us. So the number that's going to actually go in the box is actually -4. Sorry, that's my metal cup. I keep hitting it with my pen. All right, and then my coefficients, I've got 2x to the third, 3x squared, -16x plus 10. All right, so bring down the 2. All right, so 2 times -4 is -8. 3 minus 8 is -5. -5 times -4 is +20. -16 plus 20 is 4. 4 times -4 is -16. And 10 minus 16 is -6. All right, so it's going to be 2x squared minus 5x plus 4. So if I was doing this like the previous way, I would just put this over x plus 4, but they're asking us to write the answer in the form of f of x equals x minus k. All right, so it's still, so what we're saying is that this original function, it's kind of like we're factoring it basically. So we're saying that function there is also equal to x minus k, so x minus -4 would actually be x plus 4, times q of x, meaning the quotient. So in this case, the quotient is this right here. It's the 2x squared minus 5x plus 4. Okay, plus the remainder. So in this case, the remainder is -6, so we can just say -6. All right, so what we're saying is that this polynomial can also be written in this form. All right, and then number 6, same type of question. Okay, so I'm going to put +2 in the box, and then my coefficients are -1, 1, 3, -2. All right, bring down the -1. -1 times 2 is -2. 1 minus 2 is -1. -1 times 2 is -2. 3 minus 2 is 1. 1 times 2 is 2. -2 plus 2 is 0. All right, and then, all right, so it's -1x squared minus 1x plus 1. There's no remainder. So f of x equals x minus 2 times -x squared minus x plus 1. And then since the remainder is 0, I don't think they need you to put a +0 there. I could be wrong. I'm not too worried about it. You'll figure that out when you do the homework. All right. Okay. All right. Okay, the remainder theorem. So the remainder theorem says that f of k equals r, where r is the remainder of f of x divided by x minus k. All right, so this is kind of just a shortcut to evaluating, the polynomial at a given x value. Okay, so we're going to, again, in this case, we're going to put 4 in the box. All right, and then our coefficients will be -1, 8, and then it skipped the x, so we have to put a 0, then 63. All right. it takes longer to actually say all of these little operations that I'm doing than it does to actually just do them, I think. All right, so so in this case, they're just asking you for basically the remainder. So f of 4 is equal to 127. That's what they're looking for here. All right, this is all leading somewhere. We'll see the full culmination of it all in section 3.4. Okay. All right, so if f of k is equal to 0, then k is said to be a 0 of f of x. All right. The zeros are also, at least the real zeros, are also the x-intercepts of the graph of a polynomial. All right, so the question is 1 a 0 of this polynomial? So to answer that question, I'm going to just put 1 in the box. So basically I'm evaluating f of 1. And then we're going to see if it comes out with a remainder of 0. And if so, the answer to their question will be yes. Otherwise, the answer will be no. So coefficient 2, 9, negative 16, 12. Two, 2. Alrighty, so the remainder is 7, which is not equal to 0. Therefore, the answer to their question is no. 1 is not a 0 of that polynomial. All right, so that's the end of 3.2. And it feels like we're, in the middle of something. We're kind of leaving it hanging here, which we are. Like I said, it'll start to come together more in the next couple sections. All right, the end.